Hello, everyone. Welcome back to another episode of the engineering side of data. Got a great topic here today. I'm joined by Johnny Chivers, and we're going to be talking about data lakes on AWS. Johnny, thanks a lot for joining me today. Please introduce yourself.
Thank you. As Bob said, I'm Johnny Chivers. I'm a data engineer, primarily working in the AWS tech stack for over the last half a decade. Now, I switched roles a couple of weeks ago to work in the cybersecurity industry, but before that, I spent 5-6 years working in the financial services sector, building, enhancing, maintaining AWS data lakes. Aside from that, outside of the kind of day job, I also run a YouTube channel under my name, Johnny Chivers, where I just make free content pretty much on everything data engineering in AWS. And I do weekly uploads there from the very beginner kind of stage right up to the kind of professional stage, depending on what you're trying to do. And then alongside that, I also dabble in a bit of web design. So I created an app called the QuestionBank.io, which is a completely free resource where it kind of contains 100 questions. And we're building that all the time for your AWS certifications. So you can go visit that at the QuestionBank.io. And from there, you can sign up and then start heading towards AWS certifications with questions for free.
Nice. Yeah, folks, go out there and check out Johnny's channel, his YouTube channel. All that will be in the notes in the podcast, and on the YouTube, it'll be in the description. Make sure you check it out. He's got a lot of great content out there. Put a lot of effort to it. Good stuff. Subscribe and like every single one of his viewers. Every single one of his videos, and then go ahead and create some additional YouTube accounts and like and subscribe all the videos there too. So just kidding. All right, and thanks for coming on. Let's see, why don't we jump right into the questions here? So what is a data lake exactly?
That's a controversial question in the community sometimes to start with. Fundamentally, at its origins, the data lake itself is just the central repository of structured and unstructured data. It's nothing more. It's not the compute. It's not what we use to organize the data. It is quite simply where the data is stored. And in saying that, that can be a very small data lake up to a massive scalable data lake. The definition itself has got a bit more blurry as the technology has got better over the last decade. And people would start to add in the compute side that you use to look at the data as part of the data lake ecosystem. But as the data lake itself, fundamentally at its heart, it's just storage. And in terms of that kind of storage itself, it would have started on a file system originally, just on old disks lying around. And that was the idea of a data lake, that you could run it on old hard drives. But as we've moved into the cloud and things have got better, now you would host it in AWS and S3, Azure, you would use something like blob storage. File systems still are available and out there and are still widely used. But as we move into the cloud, we're moving towards that cheap storage. So in answer to the question, fundamentally, it is just the storage component of where we put the data. But as it's got better over the last decade, the ecosystem itself has started to include other things like compute and the catalog. And I'm sure we'll get into the kind of the weeds of what exactly that is over the course of this podcast.
Yeah, absolutely. What are some common use cases with data lakes?
Anything and everything I have seen them used for over the last 7 years. So, the data lake fundamentally started as a place where companies, financial services, the web companies like Facebook, companies that produce a lot of data, didn't quite know what to do with this data, but knew they couldn't afford to put it into a traditional warehouse. So they started creating the lake concept where they would say, let's forget about ETL on this data. Let's forget about cleansing this data. Let's just put it somewhere and then try and do something with it. And that's really where the data lake started. It was an analyzation tool where you would dump as much data as possible that you wanted, and you were paying it cheap on storage, and then figure out what you would do with the data after by analyzing that data at scale. And that's probably where you've heard things originally like Hadoop came in and MapReduce. And obviously we've moved away from those kind of compute sites now, but that's where it all started. Now, the lake is developed into this whole catch-all stuff where actually our tools for analyzing the data and working with the data that we've stored have got a lot better, which means the lake use cases have moved progressively along over that period of time. So where it used to be a kind of catch-all, figure out what to do, this day and age, I have lakes that are running for in companies today, where we take the data and serve it straight out to business users that they could use it directly. Data analysts would still use that data. Data scientists love the data lake where they can go in and get all the raw data that they need to start forming their models and AI algorithms. And then even more recently, one of the financial services company I was working for, we put the lake in the heart of its brand new application. It was serving data out into customers' applications via a cache, admittedly. But what it was being used for was bringing together a load of different data sources, disparate data sources, and then centrally storing them in the lake and then pushing that out to a cache for a web app to hit. So it's went from that catch-all to now even supporting applications and organizations where I've worked. And that's really the drive of the data lake. It's let's get all this data and then do something with it meaningful from a business perspective.
Yeah, I would echo that. I've seen that as well. You're right. In the beginning, it was, we have all this data. We're not doing anything with it currently, but we just might someday. So let's go ahead and dump it in there. A lot of not so great things became of that, but they do seem to be more purpose built nowadays. And including, like you just brought up, was that, this idea of supporting applications, right? This centralized, maybe even a data hub of sorts. Right, I've seen that application grow, not just in the analytics space, but again, the application space as well.
Yeah, and fundamentally, as you said, it started as that catch-all. Then the BI team came along and started creating dashboards out of it. And then I think the application team must have saw the dashboards and went, well, hang on, this must be easier than us just going and getting this data and remodeling it. And the whole thing kind of took off from there. And I think as well, when I talk about the lake, fundamentally it's the storage, but it's also as the compute side of what we use to actually look at the data in the lake has caught up with the amount of data that we have, that we can offer these different solutions to different problems along the way. And the open source community behind the data lake movement, whether that be the likes of the Presto DB engine or the Hadoop community or the Hive community or the Spark community, the Apache community as well that look after the likes of Parquet, which is the format we'll get into that you can store data in the lake. There's such a drive behind it from open source that it's gathering speed at a rate of knots, and it makes those kind of use cases be more realized than they used to be. If you came maybe 7 years ago with the data lake and said, hey, I want to run a client-side app off it, you would have been looked at and probably told, you're going to need to go get a database somewhere. We can send you the data, but you're certainly not going to run your app off it. Yeah,
for sure. You've talked about some of the good things about data lakes, right? It's people are building them with more intent, right? Careful planning. The cloud has certainly helped, right? You've talked about S3, Azure Blob, the GCP stuff. So that makes it even easier, right? But what are some of those pitfalls with the data lake?
Like all good things, its major pitfall is its fundamental good thing, which is the volume of data you can have in a data lake. And that comes from different sides of things. So you've got the volume of data to get into a lake in this day and age is huge. And even with cloud technology, that can still be struggling. So I worked for a financial services company, one of the future exchanges based out of America and around the world. I won't name the company, but you can probably work it out from that. And we were dealing with trade transaction volume that we needed to get into the data lake to be looked at later in the day for end of day reporting from BI. And because the transactional trades are done on a millisecond, there was a lot of issues trying to get those route down to S3. You couldn't actually send them in real time into your data lake directly. And that's where streaming technologies like Kafka came in, where we would put them onto a Kafka stream. But even then, we couldn't write them off the Kafka stream directly. We had to build a Flink app in the middle, which is another open source tool, which is great for reading real-time data off Kafka, and then buffer that down so S3 could actually handle the reads. So the volume of data in the sense of getting it in can still be a challenge, but with the open source and the amount of tech we have, we can get there. And the cloud, as I said, has really helped out with this because now storage is cheap, trying things out is cheap. There's no overhead to going out and trying a solution and it not working from a capital expenditure point where you're now sitting with a load of hardware that you're like, we can't use this anymore. It's a spin up. Oh, that didn't work. Spin it back down. And then with that volume of data, there's governance concerns that come in. If you're landing a lot of data in a daily basis. It needs governance in terms of it needs cataloged, but it also in this day and age of like GDPR and things like that, you need to know from a legal standpoint what's in your lake at any given time to make sure you meet the legal requirements where you are. And then on top of that, after governance, there's good old security. And I don't even mean security externally from a lake, because if you're working even in this day and age in a lake, in a hybrid cloud environment where you might have an on-prem and off-prem, the lakes are usually pretty secure by the team anyway. You're very unlikely to be able to penetrate in, set up right. But security internally is becoming more fundamental, especially with the likes, again, I'll mention GDPR laws or HIPAA laws in America, where there's only certain people who have a business need can see that data, and that includes production data. And that can start to become a real headache to try and manage in a lake where you have a high volume of data. And especially if you're a catch-all, you need to know everything that's coming in, being moved along, and actually what the classification of that data is. And then, as I kind of hinted as well, the lake has progressed, and we've talked about this into the realms of applications. So because you have that volume of data, people expect more from that volume of data in terms of what they're able to do with it. So they might think it's like running on a small MySQL database, or if they were to download some data locally and run some Python code across it, like a data scientist would do typically. They expect now the data lake to be able to handle that. So the pitfall of the data lake is, yes, you have all that volume of data, but if the users can't get at it in an efficient way, then it's not any good to them either.
Yeah, absolutely. I think, if I were to put a central theme around a lot of those pitfalls you mentioned is, man, we miss databases. We're not dealing with a data lake, right? The transactions, the security model, and then people go, well, okay, well, how do I update a record, right? And there's some things that have come along to help that out. How do I, GDPR, I need to delete this customer at their request. Oh boy, how do I do that in a conventional data lake? Again, things are improving every day, but yeah, you start missing a database pretty quickly once you start working with a data lake.
You really do at times, because the fundamental features of a database have been hardened over the last 30, 40 years. And a data lake destroys those concepts in an instant. Yeah. And the 10 years, it was like, here's all this web data, essentially is where it started, really, with the likes of Facebook, just getting all their data in and then trying to analyze it through MapReduce. And they weren't particularly concerned because it was just looking at like web traffic and what users were kind of doing on the platform. And as legislation has caught up with what actually companies are doing with their data, then it's kind of like, oh, we really, the database really was built for this. And data lake technology is now looking at a database and saying, right, we need to catch up to the database level of security and governance, or else we're dead in the water. And I think, thankfully, over the last 3 years, it really has. But it's getting that rolled out now in the systems to say, yeah, we are completely compliant, and this is why.
Yep, pretty tough. You mentioned, we touched on consumers a little bit about the data lake, right? You mentioned, obviously, you got analysts and data scientists, and you also mentioned applications, right? Let's start with the more on the, I guess, the analytics side of the house. How are people getting at that data, and what kind of tools are they using to access data in the data lake?
Yeah, I mean, my experience is over the last kind of 6 years is AWS, and it's kind of mirrored no matter what data lake you're using. You've got all this data, and you've got data scientists or data analysts or BI guys who want to build dashboards and analytics out of that data. And they're used to either a database connection or self-serving themselves files off their laptop. And the data lake slightly changes that concept, where the data volume is so high now, those technologies don't work. And kind of in their place, cloud providers have came up with their own solutions. So in terms of BI dashboards, AWS have their own version now called QuickSight, where it can hook directly into a data lake using an Athena connection, which is a Presto engine underneath, and that's completely open source. It was developed by Uber, and it's kind of the gold standard of using SQL against the data lake, which is also great. Fundamentally, before you had to know Java really to get at big data, but now we've gone down the kind of PySpark and SQL route, which is great. And that's the AWS offering. But the likes of Tableau now have an Athena connector, so you can connect in from Tableau. There are other offerings, such as, one of the big buzzwords around right now is Snowflake. It operates slightly different, where your data would sit on S3, but come Snowflake time, it would actually then lift the data that you want into a virtual warehouse, into its compute nodes, and then hold it there where you do your analytics and then drop it back out. And that's, just some examples. Qlik have their own offerings as well. I've worked on the Qlik platform over at Data Lake, began life called Podium, and it was actually bought out by Qlik. And it offers its own kind of ETL studio inside the Qlik data catalog now to work with the data and then produce dashboards out of the Qlik dashboard on top of it. In terms of then data scientists, the likes of AWS have SageMaker, which is a fully ingrained, custom-built data studio that just integrates straight in with your AWS data lake on the S3. And there's no issues there with them using that type. Alternatively, on top of the AWS, even have things like Athena, which is a serverless access point for Presto up there. I saw data scientists and data analysts access the data there. Business users in particular, in terms of AWS lakes, they're quite comfortable, or I find that they're quite comfortable using Athena itself because it's a simple query engine for them. The downside to Athena is the expense. At the moment, you are paying $5 per terabit of data scanned, but in terms of an operational overhead, in terms of not having to retrain business users, it is a reasonable trade-off at the moment, until maybe something more proprietary or open source even comes along and replaces that ease of integration.
Yeah.
And then the app side of thing as well, building apps recently, and a lot of data lakes now, or a lot of applications, there's an open source connector in through Athena as well. So you can actually ingrain Athena into your app and then call it asynchronously or synchronously, whatever way you want to do it, and then access your data lake through there to the app. And then there is third-party tools as well, as I said, that are coming along and building their own access points into data lakes on top of it. Anaconda, the studio itself now can work with S3 if that was the way you're inclined to access through Python, for example.
Oh, man. Didn't know that. Yeah, you mentioned Athena. I'm a big Athena fan. And it is a great way. It's serverless. It's relatively cheap, right? And it is pitched as an exploratory solution. If you do find yourself maybe having some dashboards or reports that are run with some frequency, you could always, if you want to, spin up EMR, get Presto going, and use that to access it. But if you're doing some exploratory stuff or it's light use, man, Athena you can't go wrong. I'm a big fan.
Yeah, I mean, recently, the last organization I worked for before I moved into this cybersecurity job, we were running a data lake backed on S3, but our access layer for analysts was actually through EMR, through Hive, actually. They were using a Hive login. Not great, but that's the way they were accessing it for a cost reason. Our security at the time, where they were running Apache Ranger, which again is open source and actually helps with access to the data, works off AD groups to permission who can see data, a bit more like a traditional database. But then they would log in and use Hive to look at the data. And at that point, it would lift the data off S3, put it onto the EMR nodes, and then the user would then, Hive query would then run against it, and they could actually view the data that way. And the last thing we did there was actually transition them off that EMR cluster to Athena. And the reason we did that was that the EMR cluster was 50 nodes. It was up pretty much 7 days a week, and we were taking it down on a Sunday to recycle it. And in terms of cost analysis, in terms of how many issues we would have with having to recycle things, losing nodes, building nodes back in, and then even have to manage the elasticity of that cluster to deal with things at peak time, and then the operational overhead of the DevOps team plus the team that I was on, it just was no longer cost effective. It was easier to pay the Athena cost than actually maintain that cluster for that purpose. Even though if you set out the Athena queries versus those Hive queries, and you looked at that in isolation, the Hive query method with the EMR was cheaper. But once you took in the operational side of looking after that, then Athena won every day of the week.
Yeah. 50 node cluster in EMR is, not something that you can just spin it up and put it aside and don't worry about it. Just recycle it on the weekends. Yeah, there's a little bit more to it than that. Yeah. Good point. Yeah. How does, obviously you mentioned the volume of data, right? I mean, that's typically where a data lake sells. You get lots of data in there, right? So how do we keep track of all this data that we've got lying around?
Trickily sometimes. There was a real race to market I would say 7 or 8 years ago for a tool that could catalog the data in a data lake correctly. And now there's a couple. I've worked with a lot of them over my career. Calibra is kind of the leading one, but they won't touch organizations unless you have more than a $500 million turnover a year. That's the kind of enterprise size that they look at with their product. And you're talking anywhere between $100,000 to $500,000 plus for that product. So that's the kind of money that they're looking. But that's fully governance, HIPAA compliant. You can actually start analyzing and running data queries from inside Calibra and attach your own clusters into it. So, it's got a lot of bells and whistles. Overkill for some places. I've also experienced with the Click Data Catalog. It actually started out as a thing called Podium, which was a startup. And again, it actually is a Java-based application that sits on a Tomcat server. And it was a catalog itself where it sat over your data lake, and it was able, when you laid down a file or you used its interface to actually ingest your data, it took in the metadata about that. Then along came an open source product called Amundsen, which was by Lyft, and it's now looked after by the Linux Foundation. And again, it integrates with data lakes to look after the data. So it can actually look at S3 and infer things. But more commonly, what's happening these days in the likes of AWS, there's the Glue Data Catalog. The Glue Data Catalog is a Hive 3 metastore abstracted away from the user. So it contains what I would always call the technical metadata about your data. So it's location of the data, size of the data, what format the data is in, what columns the data has. And that's great to have as a technical catalog. And then it integrates into other AWS ecosystem tools. And then it makes analyzing the data easier because you have your schema essentially on hand. What it's not good at, or not fully good at, is the business side of a data catalog and keeping track from a governance point of view. And that's where I think something like Amundsen comes into its own as an open source project, where you can actually ingest your Glue Data Catalog and then add those business definitions alongside. And then you get that full data catalog experience that you need in this day and age to govern your lake completely. Now, it won't suit everybody's needs. And, especially at enterprise level, aren't always open to open source. And you may want to go down the more expensive route of the likes of Click Data Catalog. Calibra and Informatica have an enterprise data catalog as well that I've worked with. It actually has its own Hadoop cluster. And then essentially it ingests all the metadata from your Glue Data Catalog or your Hive Metastore, and then does profiling on the data as it sits as well, and then populates that information. But again, those licenses are well into the tens of thousands of dollars. That's what you'd be talking about for something like that.
Wow. Yeah. I have some experience with the Glue Data Catalog. I would agree. I don't think a business user could search the Glue data, the Glue catalog, and come up with something meaningful, right? There's nothing that says, hey, where do I get the sales information? Or, the typical things that come with the more mature data catalogs that are business focused.
Yeah, I mean, the Glue Data Catalog at its heart is just, if you think about it, it's just a database schema. It's like if you're in a client database, whether that be Microsoft SQL Server or PG Admin for Postgres, it's essentially the left-hand side Object Explorer, just in a nicer format.
Good point.
It's almost viewed.
Yeah.
Yeah.
Very true. But I guess the silver lining is if it can be improved and people are asking about it, AWS will certainly deliver it, right? So
they will.
Yeah,
they will.
Absolutely. Very good about that. We've talked about schema on read, right? We kind of talked about, not without naming it in the beginning, right? This idea of, hey, let's put this data in the data lake, and maybe we'll need it. But we don't really need to concern ourselves with the integrity or the structure of it right now, right? So we got schema on read. Maybe that's kind of considered maybe more the legacy approach. But then you also have schema on write. How would you describe the differences between the two, and what do you favor?
Yeah, I mean, if we think back to the world of databases again, where all our data dreams began, schema on write's traditionally what you would see there. And we've all been there, where you're writing an ingest program, whether that be something in Microsoft like SSIS or even in the PostgreSQL. And the next thing your code spits out an error and says, cannot put in this row, data type mismatch or something along that line. And then you sit there and you go, right, I've got a file of 3 gig. I'm now going to have to go into this file, find the row that's causing me a problem and look at that row, and then fundamentally figure out what's going on. And that's a schema on write where you're checking the data types, the lengths of the columns as you write the data down. And then fundamentally, you get the error back if there is one. Schema on read with the data lake, it's a completely different approach. It's chuck all the data down, just get it in. Yeah. It doesn't matter what it is, just get it in. And then the schema, which is your columns and data types, write it out. And then when you go to query the data, we'll check it meets that at the read time. So we're more concerned about getting the data in. And then when there's an issue with the schema on write, or on read, we'll flag it up then that you have a problem with your data. So both have the pros and cons. Schema on write, there's something wrong with your data that goes in, and if it's critical, you're going to fix it at source. But on the other hand, we've all been there, and it's like, what is going on? And it turns out there's like a road comma somewhere in a CSV file, and it's destroyed everything for you for an entire day. Yep. And now you've got a build up and a backlog, and actually you've missed the next data load coming, and then everyone's on a crisis call for the next 4 hours, and no one sleeps that night until it's back. Schema on read doesn't have those problems. You don't, it's until you actually read it. But then it fundamentally introduces another problem. You don't know if the data is always correct unless you've put some other check in on the way, and you don't know that the data will fit your schema. So what I found is that if you have some checks on the way in on the data for schema on read, you're going to be okay. But that slows down the process. The other side of it is that if you're okay with reading that data out at some point in time and it being incorrect, then schema on read is great for that as well. You just want to get the data in. And then as the data lake's now progressing, there's a real loggerhead over this. There's technologies out there now that are saying, no, we want schema on write for our data lake. And there's other people saying, no. Historically, it's always been schema on read, and we're going to keep it that way.
Yeah.
And it's a real loggerhead.
The analyst problem.
Exactly.
Schema on read. Push that ball down.
Down. We didn't output this data. It didn't come from us. Yeah. We got it from some legacy system over there.
You're going to have to talk to the application people. We don't know anything about that.
I sometimes find with a data lake, by the time the data gets there, it's been through that many processes, and it's come downstream from, a source system that has a well-defined schema or a warehouse that someone's already pigeonholed it into, that by the time you get the schema on read on it, the likelihood of something going wrong is a lot less than if it was an application database at source where it was taking in user data or from a form or something. And that's really what you hope with a data lake, is that the data that's coming there has been through that amount of trials and tribulations, that by the time it gets there, it's in a decent state. That touching wood, obviously, as much as possible at that point. But that would be the idea behind it.
So in a data lake, there's essentially files, right? What kind of formats are these files typically, right? I imagine CSV could be one. What are some of the other formats that are out there?
Yeah, I mean, the idea of a data lake is initially that you can throw anything at it and it will take it. So JSON, CSV, .text is very common as well. Delimited files, that the user has defined itself. Binary files exist as well in data lakes. The problem with that is when you go to search those files or query those files, it's expensive. In fact, depending on the volume of data you have, it can get very expensive. If you take a text file or a CSV file and it's 2 terabits in size and you're searching for, Johnny in that file, well, that query engine's going to have to go in and read that entire file to find where Johnny is in that file. So it's going to read through all that data, and it's going to be an expensive operation. Thankfully, I think Facebook started the kind of trend. I'm pretty sure they did Parquet. That's now handled by Apache and open source. They thought this isn't a good way to go. We're going to have to invent some file formats here that work better with data lakes. And that's where the likes of Parquet, and there's Orc as well, came into play, where they've took that concept of the file system and then thought about it in terms of a query engine. And what I mean by that is that, for example, Parquet itself is now columnar in format. So you're no longer reading rows. So if we had a text file and we were transitioning that into Parquet through some sort of ETL code, it would take a row, and instead of saving it as a row, it would save it now as a column. But it's even smarter than that. It actually uses things called row groups, where it will group the rows of a column together. So it will aid searching, which means if you know what your query is going to be, like it has an order by, for example, then you're storing the data in the order that query is going to run against. And then it goes a step further than that and actually creates a dictionary at the top of the file as well, which is actually an dictionary, I think, off the top of my head. And it stores all the different words that are in that file or different characters that are in that file as a dictionary and saves it just once for each character that it finds. And that means when a query now comes to that Parquet file, the only thing it needs to do is look at the head of the file to see, does that thing that you're looking for exist in the entire file? And then it also keeps further metadata at the top of the file, like max and mins of counts and columns and words and strings. So that query engine now needs to just read the head of the file to know what the max and min of the file is, and actually, does the thing I'm looking for exist anywhere in this file? And from that point, then with Parquet, you're able to efficiently start searching large volumes of data because you're no longer reading everything in that file structure. And Orc fundamentally works the same, except its compression algorithm is higher. Which means it's cheaper to store it, but it can cost a bit more to uncompress it. But Parquet really seems the way that the data lakes in terms of the open source community have picked their weapon of choice. Every tool works with Parquet. Orc is pretty wide regarded. You're going to get 90% of tools working with Orc, but for the open source community themselves seem to have headed down the Parquet route, and the proprietary firms seem to have followed them as well now.
Yeah, that makes sense. Yeah, Parquet is one of the smarter formats, I guess, right? I mean, that's who knew that all that metadata was packed into one format for one file. So yeah, good stuff.
Yeah.
What about partitioning, right? You hear about that with data lakes. Why should I care about partitioning? What does it give me?
Yeah, so it's the yin and yang of optimization is Parquet and partitioning. The two things that go together, and they can either destroy your query performance or enhance your query performance, and depending on how you do it. Like any good optimization technique, like back in the database days where it was here, just chuck a non-clustered index at that table and hope for the best. Partitioning works at the folder level. So fundamentally, as you've already said, Bob, it's a file system. And file systems have folders. And if we were to take a traditional file of data, and we'll keep it with people because a person table is always good, where maybe we had a bit of person and address data where we had the country that the person was born, then we had their first name, their last name, and their date of birth. We could store that as a Parquet file inside one folder and make that one table. And that would work because we could store it in order of country, because our analysts always come in and search UK, Johnny Chivers, and they always come in and search USA, Bob. And that would work. But actually, you could optimize that further with partitioning. So partitioning is where, instead of, in this example, the country, because our analysts are always searching on country, resides inside the file, we could actually create folders of all the countries we have, like start at A, which would be something like Albania, something like that, and finish at Z, like Zimbabwe. And then inside those folders, we would store the Parquet file, but this time it would only contain the first and last name of that person, which means when the query engine goes and the first thing that analyst says is where country equals USA, it knows to go straight to the USA folder and only search inside that USA folder. Or if you were to do a query that says search USA and UK, then the engine in parallel could go to the USA folder and the UK folder at the same time and ignore all that other data, which means effectively you've cut that down by maybe 99% of the amount of data that the actual engine has to look at. So good partitioning strategies then rely on what the use case is, because the partitioning strategy has to reflect either what the end user is querying or what maybe you're doing further upstream. So traditionally, for example, in financial exchanges, you would partition by trade date, because everything comes in a date and then the next day you switch trade date and we're looking at trades by date, and that makes sense. However, further downstream, once that's been processed, analysts might come and say, I know as well as date, I actually want to also look on, stock ticker, because I'm looking at tickers, which means, okay, well, we're going to ETL this data into another part of the lake. And what we're going to do is keep that trade date as the first partition. Then we're going to take out the stock ticker on the file and put that as the second folder, so it's subfolder. And then in Parquet, we'll store the rest of the trade information at that level, which means when that analyst comes in, they can go trade date of, September the 2nd, 2021, and stock ticker AALP for Apple. And then they only have the Apple trades quickly. Well, if we didn't have that partitioning strategy and we kept it as day, it would have to go through that entire day's trades to work out and grab the Apple ones. And that's the height of a good partitioning strategy. You're getting quicker queries or quicker analytics, quicker processing, and fundamentally, it's cheaper.
Yeah, right. With something like Athena, where your pricing is based on terabyte scan, right? If you can reduce that I/O and you don't have to bring as much back, absolutely, it's a good way to save some money. That combined with Parquet for the compression, right? Yeah, absolutely.
Yeah, and I would say as well, a lot of user education around this goes in handy. A lot of business users, not to go on business users, are used to going into a SQL type of database, whatever engine that is, and just writing queries, and they go rogue, and it doesn't really matter because you're paying all the time for it. While the likes of Athena, a good user education, even for an hour, with a good document that says, like, use a where clause on your SQL statement and use only these where clauses first in this order. So in the example I give there, always use trade date and then use country. And even if you want all the trade dates for the year, still put in the trade dates with a between clause for the year and then put the country, because we'll be holding 7, 10, 9 years of data. Well, if you don't, you're literally going to search every single USA folder in every single trade day that we have up there. So a good user education experience, and as I said, it doesn't have to be complex, can really bring back results quickly.
Yeah, that's an excellent point on that one. Yep. Yeah. We've talked about S3 has come up a couple times during this conversation, right? It's arguably the leading object store, and probably more data lakes are built on S3 than any other provider or service. Yeah, what's so good about S3, I guess?
Yeah, so as I said, like my experience is AWS data lakes for the last kind of 5 or 6 years, and my first experience at data lakes was taking a Hadoop on premise to S3. And if we look at what that was on premise, it was a load of just disks, hard disks, the old spinny drives as they used to be, and cheap enough, but not the most reliable pieces of tech. And on that system of Hadoop, what it would do is store your data 3 times across your entire cluster. So if you had 3 separate nodes, that one piece of data, such as Johnny Chivers, would be replicated across those 3 different nodes, or 3 different servers, or 3 different hard disks, however you want to think about it, conceptually in your head. And it was kind of expensive. It wasn't cheap, but it wasn't exactly dear. It was dear, wasn't cheap, same thing. And along comes S3 from AWS and says, right, you can bring your data up the S3 and we're going to charge you cents on the gigabit that you store. And we're like, okay. And best of all, it has redundancy built in out of the box where your data will be replicated at least 3 times across 3 physical different locations within the region that you specify. So a lot of people operate out of North Virginia. I think everyone pretty much at some point operates out of North Virginia. It has 5 or 6 data centers now. It might be up to 6, or what AWS called AZs, availability zones, but physically they're data centers if you're in old speak, but they call them AZs. And that means when you store an object, the S3, it will get replicated 3 times across 3 data centers, which means if something catastrophic happened to one data center, you've still got 2 copies of that file or object in S3. So that's kind of from a redundancy and cost point of view. And then it's the integration. It's a fundamental service in AWS, and then they have built every single data lake technology in AWS, and analytic technology for that matter, off S3. So it integrates into their ecosystem perfectly. If you can get it in the S3 in AWS, you can pretty much do anything with the data at that point. The world is your oyster. The only thing stopping you usually is cost at that point. Just making sure that you don't have an analyst away firing up a GPU server somewhere in a data center trying to crack passwords or whatever it may be.
Yep. Yeah, AWS is built a great product with S3, and they've marketed it pretty well too, and priced it pretty well as to make things even better for them, right? Make it cheap, super cheap for people to store stuff there, and then the rest of the compute and everything else will come with it.
Yeah, I mean, I think it depends on the region you're in, obviously, for your S3 pricing. But I think the last time I had a look at it, it was about 3 cents a gigabit in Europe for the month for that object for a gigabit, like 3 cents. That is nothing.
Yeah,
in the scheme of things.
Yeah, cheap and durable, right? That pretty much sums it up, right? Yeah. AWS is. I don't recall when they came out with lake formation, but it is relatively new, and they've been putting out a certain amount of effort in improving lake formation. What is lake formation?
Yeah, I think lake formation was announced last 2 reInvents ago. It was a soft launch, and then the reInvent just passed. So the one kind of like this time last year, so a year ago, was when they really came out with a fully fledged offer of lake formation. And to kind of understand what lake formation is, you just take a step back to the old data lakes and managing security. Most data lakes were managed by a thing called Apache Ranger. And Apache Ranger sat over your Hive Metastore. Your Glue Data Catalog would be in modern AWS terms, but Hive Metastore is the same principle. It was tables, schemas, databases. Ranger sat over the top of that and provided access to those databases the way you would traditionally do it on an on-premise database or an RDBMS database. And it would be granted usually through AD groups. So again, similar to what you would normally do. And that could integrate in with your AD provider, be that Microsoft or an LDAP server, depending on how you were running that. And that could also be done at an individual level as well, if you were desired. And that's pretty much how security around data lakes was managed for a very long time. And then Lake Formation came along and said, well, we know in AWS, a lot of you guys are running your lake on S3 and you're using EMR for your compute, and then you're running Ranger on top of EMR. And this is all a wee bit complex. So we're going to come along and offer our own security offering with Lake Formation, and we're going to enhance that as well. So the days before Lake Formation, if you weren't using something like Ranger, you had to use IAM permissions to grant accesses on resources within your data lake. And that meant using like the ARN, the resource name inside your role that you were using to access the data, which was a pain to manage for administrators. If you had access to 100 tables, you would have 100 ARNs sometimes in there, depending on how you set it up. So that meant a lot of people went to Ranger. And AWS went, right, we need to come up with a solution. And they did, which is where Lake Formation comes in. Quite simply, you register your S3 buckets as your data lake inside Lake Formation. You use the Glue Data Catalog as you would to set up your databases and tables about the underlying information on S3. And then for security, you can actually put your AWS user or the role that you assume into Lake Formation and then grant it permissions. So you can say, this role of data analyst has access to database A, B, C, and table E, F, G. And that was kind of the first offering of Lake Formation, but people said, well, actually Apache Ranger grants column access and it grants row access on tables as well. So not only could a data analyst see a table, we could actually stop them seeing a column or seeing a row. And AWS said, no problem, we'll bring that along. And they brought that along with the latest offering of Lake Formation, and it's now rolled out globally, where you can go in and not only grant access at table level, you can grant access at column level, and you can grant access at row level. And even further to that, they said you can actually grant access at cell level. So there's a particular cell in that table, if you think about a table when it would be constructed, that you don't want a user to see, be that because it equals, you might be storing your data like HIPAA ... and then a health number. And then you'd be like, don't show anything that has HIPAA. Just don't show it. If it says HIPAA in the string, don't show it. And you can start blocking things out at cell level with Lake Formation. And then Lake Formation, when you add in that user, it automatically grants all the permissions to that user. And then it can also obviously take that all the way. And that's done through an administration role. So you're back into that old database administration technology where a database admin is granting access to data based on role or user at table, row, or even cell level now. And that's the idea behind Lake Formation. Something that would have took you maybe weeks to solve originally can now be done in a matter of hours. Like I've spun up a basic data lake in 2 hours now using Lake Formation with full security around it.
Wow. Yeah, that certainly makes it sound like it's a lot easier than the old IM days for sure. Yeah. And I know that Lake Formation is primarily focused around the security aspect and making that much easier, like you just explained. But it's recently come out with something called governed tables, right? Can you explain a little bit about those?
Yeah, they were announced last reInvent. One of the criticisms of data lakes, as we touched upon it earlier in the conversation, is the upsert business or the delete business of data lakes, which a traditional database can handle. And over the last couple of years, an open source project It's now an Apache called Hootie was developed. And the idea of Hootie was to sort out this upsert and delete business of data lakes, where you have all your data sitting in your table structure on the file system. And the idea was that Hootie, if you applied Hootie over this, you could keep sending data in and tell it whether it was an insert of data, an update of data, or a delete of data. And using the primary key, either on read or write, that was your preference. And usually people did it on read. It would lift all the existing data when you wrote a query, lift all the new data, and in memory do a comparison on the primary key and work out had that data changed since the last time it was stored in Parquet. If it had changed, they would apply that format to the Parquet file and keep that as a new Parquet file, return your result set, write that new Parquet file down, and remove the data that was sitting there before that needed to be upserted, deleted, or inserted. Governed tables pretty much work off the same premise, where they're saying moving away from the traditional data lake and bringing in more of the data warehouse concepts, which is getting known as a data lake house, another great buzzword that's coming up. They've entered governing tables where they say there is the Hootie open source, but this is our solution on AWS to optimize that with S3. You want to do upserts on your data and delete. We have this optimized for S3, and this is our offering. And now you can start to treat it more like a traditional warehouse, which was the ask really of people using data lakes.
Gotcha. What is your opinion on multiple layers in a data lake, right? I mean by that is raw, and so a raw layer and a curated layer. But you also have a strategy popularized by, I believe, Databricks, this bronze, silver, gold, where the idea is it's raw. It starts in raw, but then towards the end of the layers, I guess, that it's more refined, more curated, more useful to the average user. What is your opinion on those?
So every data lake I have worked in has used bronze, silver, and gold. I've never worked on a Databricks offering. I've worked on Hortonworks, Hadoop on premise, and then in the AWS for the last kind of 5-6 years. And every architecture that we've used has had a bronze, silver, and gold. And the idea, as you said, is the bronze is where your raw, unprocessed data sits in its rawest form. Silver is where you validated that data. So in terms of financial exchanges, a lot of checks would happen on sequences to make sure that all the messages arrive from the trade, because you might want to rebuild the order of which they arrive for an order book. And that would be the silver. And then the bronze would be where you've enriched that data. So you might have trade data and you might have customer data, and then you might tie those two things together. Maybe like a join in a traditional database, you would do that in ETL and then land that as a useful table for end users. And where I found it comes in best is to stand over the data governance proposition of quality and say to users, look, that bronze data has not been verified. It has not been checked yet. It's the rawest form. If you go lift that as a data scientist, we will not guarantee that it's been in its purest format. If you lift it from the silver, where we have verified that we haven't missed any messages, and if we did miss messages, we would go get them from another store to make sure we can fill the blanks up. You're solid. We can stand over that. And then the gold would be business level. And again, you'd say to someone, well, if you go lift that has business logic applied to it in the gold layer. So yes, it may be what you think it is, but also someone requested that to be an algorithm to be applied in a certain way to that data before it was landed. So it may no longer be the definition that you think that field is. And that goes back to the data catalog, where you would say, but you can't find that out in your business data catalog. So go check that out and see actually what the definition of that column is by the time it gets to the gold layer. If it meets your criteria, go and take it. If not, we've actually got it in the silver layer in a format where we've checked it, but we haven't done anything to it yet, like cleansed out nulls or removed blanks or something like that. But there's it in its rawest format. And that's where I find the bronze, silver, gold comes in. I never get too hung up on, there's that old meme going around the internet about the company that went out of business because they couldn't name a variable. And I always find it's code. I always find sometimes when you're having that architecture meetings about data and bronze, silver, and gold, you can really get into the weeds about what's silver and what's gold. And I always say, look, there's a silver gold, there's a rose gold in the middle somewhere. As long as you're happy enough that it's kind of there, then just say it's gold, okay? And don't be too hung up on it. What we're really looking for here is that bronze is its rawest form. Silver is a form that we can stand over but haven't manipulated to a business level yet. And gold is that real like enriched data that no longer came from its source system as is. And that's why I stand over it, really, is when it comes to that kind of side of the data and the business and its usefulness to the individuals within it.
Gotcha. That's like a good meeting with 5 or more people. And that's when the semantics get called out, right? Maybe we should call it one. Yeah, level 1, 2, and 3. Well, what about 2.5? Yeah.
Yeah. What about this edge case that's never possibly going to happen?
Exactly, right? Well, it is Friday afternoon. Let's embellish this a little.
Yeah, we've all been there.
Yep, exactly. All right, in closing, and since you brought it up, we got to talk about Lakehouse, right? That's a term that's been a little bit more talked about in the last few months, maybe even the last couple of years. What are your thoughts on Lakehouse? Is it real?
Yeah, I think the first time I encountered it was maybe 12 or 13 months ago. I can't remember who wrote it. I think it might have been on a Medium article. And I was like, oh, this is where we're going. It's like, okay.
You thought it was a joke first, right? You thought, okay, they're driving clicks.
Driving clicks. So this is where we're going. And then I saw it come up at reInvent. I was like, oh, this is a thing, right? Okay, this is definitely where we're heading. So we've talked about a data lake fundamentally being at its heart just the storage, and we've talked about the compute side of a data lake being the data lake ecosystem. And where a data lakehouse comes in is where there's no longer that distinction in terms of what the concept is. It's the data lake ecosystem is now both the compute and the storage. And that means if you treat it that way, you can start doing more data warehousey, which I'm not really sure is an objective, but we're going there, type things with your data. Now, we've already touched upon it. Fundamental flaw of the data lake was trying to do inserts, updates, and deletes. But that's been solved by the likes of governing tables or Hoodie. And that's a lakehouse concept. That's a data warehouse concept where you would have a star schema or something of that nature, be that on premise or in a cloud somewhere, like Redshift, for example. And you would try and upsert your data into that through staging tables, nightly or hourly or whatever way you were handling your data. And that's what a lakehouse concept is. It's saying, well, you know what? We're going to take all the best bits of the data warehouse, like its upserts, its deletes, its speed, and apply them to the data lake. The only difference fundamentally, or the couple of differences fundamentally we're going to have is that, yes, the compute, the storage will always be separated because we just want high volume of data. So we're not going to run it on a server. And it's going to be a file system based like folders and files. I know a database at its heart is essentially a file system, but the engines don't quite see it that way at times. Yeah. But that's where we're really heading down there. And as I said, if you look at like the new offerings, so if you look at Hoodie, you look at governed tables, you look at the way Presto is now working for SQL, queries at efficient speeds, you can actually do ETL with Athena now. There are companies out there, blue chip tech companies, that you can ride share with, do the majority of their ETL using Presto, for example. So they're just writing SQL queries to move data from A to B. And that's the lakehouse concept, where you're starting to use it more like a data warehouse than a traditional lake that used to be get all the data in and then figure out what to do. And I think during the course of this conversation, you can see where we started, get everything in to what I've as use cases over the last 5 years have used right up to that application layer. And I think by the time you're talking about bronze, silver, and gold, you're talking about Hoodie, you're talking about upserts, you're talking about a good partitioning strategy, and you're talking about feeding applications off the data lake, you're at a lakehouse. That's where you are. Yeah.
It's just it's the culmination of all those things. Yeah. The evolution of, maybe Data Lake 2.0, maybe, but Lakehouse is a little bit more marketing
Everyone
friendly, right? Yeah.
Yeah. I mean, I think, there was in a meeting, talking of meetings, we were in a meeting one day and coming up for names with things, and we had the data lake, but then we had the place where we wanted the users to access the data lake from. And we couldn't think of a name for all the different kind of like engines or services that we were going to use for AWS, whether that be, we might put some out in the DynamoDB, we're going to use Athena for some of it, they're going to come in through SageMaker, going to come in through EMR, and we ended up calling it the pier, because the pier sits at the edge of the lake.
Yeah, why not? Just jump right in, right?
Exactly.
Too funny. All right. Well, hey, Johnny, I really appreciate you coming on. I've really enjoyed this conversation. I hope the folks at home will enjoy it as well. Yeah.
Brilliant. Thank you very much for your time. It's been fantastic.
Yeah. And everybody, again, go out to Johnny's YouTube channel. It'll be in the show notes and the description. Like and subscribe. And then make sure you do the same to this video. And if you're not subscribed to the podcast, please do so. Thank you.